Let's look at solving this initial value problem right here. Well, like I said in the last video, we need to solve the characteristic equation, which will come from r squared minus r minus 2 equal to 0. We can factor this into r minus 2, r plus 1 equal to 0. So that gives us two r values, r equal to 2 and r equal to minus 1. So my general solution is of the form c1 e to the 2t plus c2 e to the minus 1t. In order to actually use my initial conditions, we need to find the first derivative. The derivative of e to the 2t is 2e to the 2t, so I have 2c1 e to the 2t. The derivative of e to the minus t is minus e to the minus t, so minus c2 e to the minus t. We then have this initial condition here that's going to correspond to this equation here. Sticking in 0, I should get 0 back out. So this is c1 times e to the 0 plus c2 times e to the 0. Our second initial condition has to do with the derivative, this equation here. We know this is equal to negative 1 whenever t is equal to 0. So we have 2c1 times e to the 0 minus c2 times e to the 0. And if we just add these equations together, so I'm going to write the second one underneath this first one. And if I add these two equations up, the c2's cancel. I get negative 1 equal to 3c1, which tells me that c1 is equal to 1/3. My first equation had told me that c1, which I now know, plus c2 is equal to 0, so that tells me that c2 is equal to 1/3. So my actual solution, minus 1/3 e to the 2t plus 1/3 e to the minus t. So I now have my solution.